This is solving systems of equations using the elimination method. The object of the elimination method is to eliminate one of the variables, the x or the y, because we have x plus y is equal to 6, x minus y is equal to minus 4. Well, each equation has two unknowns. How can you solve with two unknowns? Well, if we can combine these, because we are looking for an x value and a y value that is the same in each. So if we can combine these equations and eliminate one of them, we would just have one unknown, and we can solve that equation, right? Well, if you see a systems of equations like this on the Regents, it'll only be on part 1. You'll never see one this simple on part 2, 3, or 4. So this one is set up for you. Look, I've got a positive 1y, I have a negative 1y. If I combine these, if I add these two equations together, these cancel out, they zero out. And then I have 1x and 1x, which is 2x, is equal to 2, so therefore x is equal to 1. And of course, you use either one of the equations, put in the number that you know, the solution for x. So in this case, y is equal to 5. So the solution is 1, 5. Okay? So this is more like the type of equation you will see on the Regents. This one, 3x plus 2y equals minus 4, 4x minus 3y equals 23. Well, combining them, just adding them like I did in the previous one, won't work, because 4x and 3x is 7x. 2y and minus 3y is a negative 1y. It doesn't get me anywhere. So I've got to do something to eliminate either the x's or the y's, and I'm going to choose, you can do either one, but I'm going to choose the y's because they have opposite signs, and that's what I'm looking for. So half of the work is done for me. So the next thing I do is I say, okay, what is the, remember this, LCM, least common multiple of 2 and 3? What is the smallest number that both of these will divide into? So the least common multiple of 2 and 3 is 6. So my goal is to turn this number into a positive 6, turn this number into a negative 6. That way they'll cancel. Well, how do I turn a 2 into a 6? I multiply by 3. And in order to be algebraically correct, I have to multiply the whole equation by 3. How do I turn a minus 3 into a minus 6? I multiply that by 2. And of course, to be correct, I multiply the entire equation by 2. All right, so now let's get our new equations. 3 times 3x is 9x. 3 times a positive 2y is a positive 6y. 3 times negative 4 is negative 12. 2 times 4x is 8x. 2 times negative 3y is a negative 6y. 2 times 23 is 46. So now, if I combine these two, look, positive 6y, negative 6y is exactly what I wanted to do. They cancel out to 0. So I'm only left with one unknown, which is the x. I have 17, x is equal to 34, and therefore x is equal to 2. And again, as always, I take either one of the equations, doesn't matter which one, and substitute for now the x that I found. So now this is 6 plus 2y is equal to negative 4. 2y is equal to negative 10. Of course, y is equal to negative 5. And so my solution is 2, negative 5. So that is how you solve systems of equation with the elimination method. In this case, it was set up for us. A positive 1y and a negative 1y cancel each other out. But this is the one you'll see the most often. I've got to look at these. Now, the other thing I could have done, if I wanted to eliminate the x's, I would have turned this into a 12x, and I would have turned this into a negative 12x. So I would multiply this by 4, and I'd multiply this by negative 3. But I decided on the y's because I have the different signs already set up. So I turned this into a positive 6. I turned this into a negative 6. They eliminated, just leaving me with the x. And that's easy to solve. So that is how you solve systems of equations, the elimination method.